Okay, today we're doing SAT Test 7, section number 3. Now, calculator problem number 7. I did this in the previous video where I did 1 through 10, but I wanted to go over this one and go over more detail and give you an alternate solution that might be a little bit easier for some of you. I know some students would like to be able to write a quadratic function in vertex form, and that's what we want to do. We want to be able to write this in this form: x minus h squared plus k. And in order to do that, we will have to complete the square on the given quadratic function. So what I'm going to do is I'm going to write x squared plus 6x plus blank. I'm going to put something here so I can complete the square on this part, and I continue with my plus 4 here. And whatever I add here plus blank, I have to subtract that so I do not change the original problem. So whatever I add here, if I add 5, then I subtract 5. Now, the rule here is going to be that I'm going to take b divided by 2 and square it and add it to both sides. So this is going to be 6 over 2 squared so that I can complete the square. So whatever this number is, b here, I'm going to take half and square it. Half of 6 is 3, and 3 squared is 9, so I'm going to add 9 here, and I'm going to subtract 9 here, and by doing this, I now have a perfect square here. This is a binomial square, so this is x, and if this is a plus here, then I'm going to have a plus there, and then 9 is actually 3 squared. So x plus 3 quantity squared gives me the x squared plus 6x plus 9, and then for this part, constant here, I'm going to have 4 minus 9, which is a minus 5. So if I look at the answers, I have x plus 3 on A and x plus 3 on B, but I have a minus 5 here, so this is a minus 5, this is the x plus 3, so the answer should have been answer B, which is what we got in the previous video. I'll attach a link for the previous video so you can see alternate solutions, but this is one way that you can complete the square to do this problem. Now, there is another way, an alternate solution, that a student could use to do this. So I'm going to show you how to do that. Okay, and our second alternate solution for this problem is that a student might take the x plus 3 squared and expand that, and then either add 5 or subtract 5 and see if we can come up with the original problem. So I'm going to take x plus 3 times x plus 3. I'm going to have x squared plus twice the product of the 2. 3x times 2 is 6x, and then 3 squared is 9. And then I have a plus 5 or minus 5. Now at this point, I need to ask myself, do I need to add 5 to 9 to get 4, or do I need to subtract 5? Well, I need to subtract 5 so that I can get this 4 here. 9 minus 5 is 4. So I have x plus 3 squared, x plus 3 quantity squared, minus 5 will give me that problem right there. So this is x plus 3 squared, and then the minus 5, and that gives me answer B. So this is another way of doing this problem. In the previous video, we said you could find h by doing negative b over 2a, and when we did that, we found out that negative b was a negative 6 over 2 is a negative 3. And then you plug it back into the function, negative 3 squared, and then negative 18, and then plus 4. That would give you the minus 5. So you have a negative 3, but since we have x minus a negative 3, that would generate the x plus 3, and then the minus 5 for k, so that would be answer B. So that's the third way of doing this problem. And another way that we showed you on the video is to plug in numbers. If x is 0, and then run it through the answers, or if x is 1, and then run it through the answers and do it that way. You can check the video. An alternate way would be maybe to graph this. This is a non-calculator section, and that would be a little bit complicated to try to graph that. Or now, one other way is maybe if you know a little bit of calculus, this would be an alternate solution. So I'll just write here alternate solution for this problem. If you know calculus, we know that in a parabola, if this opens up, you're going to have a minimum point right here, and the minimum is when the derivative is equal to 0. So when y prime is equal to 0, we can find that point, which is the vertex. So I'm going to have y is equal to x squared plus 6x plus 4. Now, if you haven't had calculus yet, that's okay. I'll show you a few basic steps in calculus. So y prime, the derivative, or shall we say dy dx, the derivative of y with respect to x, is going to be, using the power rule, you take the exponent 2 times the coefficient, 2 times 1 is 2, x, and then subtract this by 1 here, 2 minus 1 is 1, and then do the same thing here. The exponent here is 1, 1 times 6 is 6, and then x to the 0 is just 1. And this is actually, the derivative constant is 0. So 2x plus 3, 2x plus 6, and what we do is we set this equal to 0 because we know that the slope is 0. The slope of the horizontal line here, the tangent line of the curve is 0, and so 2x is equal to negative 6 if we subtract 6 on both sides, so we get x equals to negative 3. And to get y, we plug that back in the original equation, which we already did over here, and we got negative 5. And so then you take your formula, x minus h squared plus k. So minus a minus 3 is plus 3, and then your minus 5, and you have answer B. So that's using a little bit of calculus. You can find the vertex. Now, there is one other way to solve a problem like this, although in this problem it didn't actually work because the original problem is not factored. But I'm going to do an example. What if this function was factorable and they asked for the vertex? And if you know the vertex, then you could come up with the answer readily. So I'm going to move to another piece of paper here for a second. Okay, so I changed the problem up just a little bit, and I said, what if we have y is equal to x squared plus 6x plus 8, something that is factorable? So, and again, we want to write this in vertex form, or maybe we want to find the vertex. So if we can factor this, factors of 8 that add up to 6 would be 4 and 2. So I'm going to have plus 4 and plus 2. Okay, and so what we want to do is find the 0 since it is factorable. So the zeros for this problem, x plus 4 is equal to 0, and x plus 2 is equal to 0. So that means that the x-intercepts are at negative 4 and at negative 2. And so on the number line, this is the x-axis, here's negative 4, and here's negative 2. And so you're going to have a quadratic function that passes something like this. And so the vertex will be, the axis of symmetry will be right down the middle here. And so all we have to do is find the average of negative 4 and negative 2, which is negative 3. So negative 3. And that's the vertex, we'll call that V. And then how do you find K? Well, if H is negative 3, you're going to have negative 3 squared is 9. And then 6 times negative 3 is minus 18 plus 8. So negative 9 plus 8 is a negative 1. So in this case, it's negative 1. So negative 3, negative 1. If you want to write that in vertex form, which is x minus h squared plus k, then you would have x minus a minus 3 would be plus 3, and then you square it, and then plus k, this is h and this is k, k is a minus 1. So this is one way that you could write it in vertex form. If you could factor it, you could find the zeros, and then take the average of the zeros, and that would give you h, which is the axis of symmetry. And so this gives you another alternate way of doing the same problem. So there's many different ways. Now, the more you know, the better you are. And so, if you like this video, hit the like button, make sure you subscribe, and we'll look forward to the next one. Thank you very much for watching. Keep watching, keep learning. Thank you.